we're covering two sections today. We're doing 12.2 and 12.3, which are both surface area. And most of these formulas are right on your formula sheet, so it's just a matter of knowing how to use those formulas. So 12.2 is surface area of prisms and cylinders. First of all, what a prism is, it's a polyhedron, which means it's made up of all polygons with two congruent bases connected by lateral rectangular faces. I have two examples to show you. So this one is a prism. The two bases that I have my fingers on are congruent and parallel, and they're connected by rectangles all the way around. So that's what makes this a prism. Two figures that are exactly the same, two polygons, they're congruent and they're parallel, and they're connected by rectangles. Here's another example. We have two polygons that are exactly the same where my fingers are, and it is connected by rectangles. So the two bases that are congruent and parallel, connected by rectangles, that makes it a prism. So surface area of any prism, understanding what surface area is like wrapping paper, finding the area of all the surfaces and adding it together. So the surface area of any prism or any object, any 3D object, it's finding the area of all the pieces and adding it together. That's your surface area. Surface area of any prisms in general, no matter if it's a triangular prism, a rectangular prism, octagonal prism, this is the way you're going to do this, is find the area of area of the base, multiply it by 2 because there's two that are the same, and then add up the area of all the rectangles. Whether you're given it to you in a net form, which is a flattened form of a 3D figure, or if you're given it to you in a 3D form, this is your general idea of how you find the area of all the shapes and put them together to find surface area. Lateral area is new to you. Lateral area is everything except for the bases. So if you were finding the lateral area of either of these prisms, the bases don't count. You're only adding the area of all of these rectangles. Same thing with this one. So you would not count where my fingers are. Those are the bases. The lateral area would just be the rectangles for this prism. And of course, when you're talking about surface area, you always need to include units squared. Look at my first example. This is a pentagonal prism. We have two pentagons that are the orange spaces. And I'm trying to show you with two different colors. The black shows you that it's connected by rectangles, very similar to the picture I just showed you. So for surface area, remembering this general idea, area of the bases times 2, because there's two of them, so you're finding the area of these two pentagons, and then you're finding the area of all the rectangles and adding them together, and that's your surface area. So remembering from our lesson from 11.6, we know how to find the area of that regular pentagon. All we know for that orange pentagon is this side of 3. And you know exactly how to find the area of that pentagon using our skills from the apothem and 1/2 times the perimeter times the apothem. That's what I'm doing here. Use this side length, pull that triangle out, so half that side length is 1.5. Here's my apothem. My central angle is 72. Dividing by that, I get 36. To solve for my apothem, I use the tangent of 36 equals 1.5 over a. Remember, to get that a out of the denominator, you need to multiply both sides by a and then divide by the tangent of 36. That gives me an apothem of 2.1. My perimeter of this pentagon, 3 plus 3 plus 3 plus 3 plus 3, or 3 times 5, the perimeter is 15. To find the area of one of those pentagons, 1/2 times the apothem times the perimeter, and I have two of them. So this is the area of both of the bases. My rectangles, these rectangles, this one, looking at the one that it's sitting on, they're all the same. This bottom one is 3 by 11. I have a 3 by 11 and there's 5 of them because there's 5 sides to the bases. The area of the rectangles is 165. My last thing I'm gonna do is add up my bases and my rectangles. This is my total surface area. Lateral area, it's everything except for the bases. So all you need is the rectangles. We have 5 of them, and each of those rectangles is 3 by 11. So the lateral area is 165 centimeters squared. For a cylinder, for this particular cylinder, be very careful. The biggest mistake you're gonna make is just plugging in diameter instead of radius. The formula right from your formula sheet for a cylinder is here. Just be careful that if they give the diameter, of course, divide by 2 to find the radius. Radius is 9, the height is 12. We're gonna plug that in. something I want to make sure you understand is how to do it in an exact form and a rounded form. So look what I did after I plugged it in. I did 9 squared times 2 and I got 162. I'm dragging that pi symbol with me. 2 times 9 times 12 gives me the 216. I can treat this pi like a variable. So I can add 162 and 216 and get 378 and drag that pi symbol with me. This is my exact surface area. If I plug that in, this is my rounded surface area. I want you to be able to do both. The key is to treat that pi like a variable, like as if it's an x. Lateral area, looking at my formula, it should make sense that pi r squared is a circle, and there's 2 of them, the top and the bottom of that cylinder. So if we're talking about everything except for the bases for lateral area, the lateral area of a cylinder is all of the outside part, almost like the label of a soup can. You would not include those 2 circles for lateral area. So looking at my formula, this is our bases. We would not have that for lateral area. You would just have this, which would be our sides. So if you already have done surface area, this is your lateral area, 216. That's our exact. Plug that in, this is our rounded. Continuing on, this is a different kind of problem. It says find the radius of a cylinder with a height of 5 feet and a surface area of 208 pi square feet. So just like any formula, you have to be able to work backwards. This is our formula right from the formula sheet for the surface area of a cylinder. It's the same one we just used here. I plugged in everything I knew. My surface area is 208 pi. The radius is what we're solving for, so I'm leaving that radius in there, and I know my height is 5. In order to get the radius by itself, my first step is to get rid of anything that they have in common. And when I look at this term, and this term, what I notice is they all have a 2 pi. So what I did was divide everything by 2 pi. And look what happens when I do that. It's simplified dramatically. I got rid of what they had in common. So from here, this is what we've talked about very recently. You can move your 104 over to get 0 on the other side. You can either factor this or use the quadratic formula. Because this number is so big, I chose to use the quadratic formula. So again, you have to have 0 on one side, so you can see that A is 1, B is 5, and C is negative 104. I plug this into the Pythagorean theorem. Negative b plus or minus b squared minus 4ac all over 2a. This is on your formula sheet, but you should be very familiar with it. I'm not going to walk you through every single step, but at the very end, don't forget that you do have 2 answers here. Negative 5 plus 21 over 2 and negative 5 minus 21 over 2. You get 8 and negative 15. You can't have a radius of negative 15, so we threw that answer out. The only possible answer is 8 feet. If you have trouble with this, reach out to me and I can help you with more individual steps. This should be somewhat familiar to you. Moving on to 12.3, again, I'm talking very quickly. This is surface area, pyramids, and cones. Again, using your formula sheet, knowing how to use those formulas. So this is the formula for a pyramid. Be careful with this one. L is our slant height. If you look at your formula sheet, the L shows you it's up the side. It's like the height of one of my triangles. P is the perimeter of the base. In this case, this is a square. You'd have to find the perimeter of that square, and then B is the area of the base. Don't get those confused. As always, I spell everything out before I plug it in. Perimeter of the base, we have 7 times 4. 7 plus 7 plus 7 plus 7 gives me a perimeter of 28. Area of the base, this is a square with a side of 7, so the area of that base is 49. And again, the slant height is 10. If the regular height is given to you, it would look something like this. Be very careful that you don't get those confused. The purple is the height of the pyramid. Up the side, this black is our slant height. So again, I'm plugging it into this formula, 1/2 times the slant height times the perimeter plus the area of the base. Multiply that out and add, I get 189. So again, going back to lateral area in general is everything except for the base. For a pyramid, the base is what it's sitting on. In this case, it's a square. So what you're finding is the area of all of the triangles only for lateral area. If you look at this, the area of the base is here. It stands out pretty well. So lateral area is only going to be this part. If you've already found surface area, you can see that it's going to be 140. If you're not sure, of course, you can always use your formula sheet. It tells you your lateral area, but I do want you to understand why this looks so similar to this and where it came from. So again, lateral area is 140 meters squared.